In this problem, we are to find the exact value for the average rate of change of the function f of x equals sine x over the given interval. To visualize what we're finding here graphically, I've inserted a graph of y equals sine x, and the picture's a little blurry because I literally just went to my graphing calculator emulator, typed sine x in my y equals menu, and then told it to graph it over the window negative 2 pi to 2 pi on the x-axis, and of course negative 1 to 1 on the y-axis. So this is what the calculator gives, which is to be expected. This would be negative 2 pi, this is positive 2 pi, and of course this is negative 1 and 1. So graphically, the average rate of change of a function is the slope of a secant line connecting 2 points on the curve, and those 2 points would have x values of pi over 3 and 4 pi over 3 because those are the x values in the given interval. This is x of 1, this is x of 2, if you will. So not that this is exact, notice that the 2 pi that we have for our x max does not hit this tick mark right here. So this is not exactly 2 pi, but if it were, then this would be pi, and then since there's 3 equal intervals in here, this would be roughly pi over 3. This would be roughly 2 pi over 3. This, of course, would be 3 pi over 3 simplified. This would be 4 pi over 3, and that's enough because our x values of pi over 3 and 4 pi over 3 are now written here and here. And now, since our job is to find the average rate of change, and since graphically the average rate of change is the slope of the secant line connecting the 2 points, whose x values were given here and here, I can locate that point on the graph by moving over to pi over 3, and then up here on the curve, and that gives me that point right there. And then do the same thing for our second point, whose x value is 4 pi over 3. I'm moving over to 4 pi over 3, and it looks like I need to move down to this point on the curve. So not that these 2 points are placed very accurately, but you get the idea. Now, if I was to draw a line connecting those 2 points, that would be the secant line. And I've drawn that secant line in red. Now, the slope of that secant line would be the average of change, and that's what we're trying to find. So, of course, now we need to find the 2 outputs of those 2 points so that we can calculate the slope arithmetically. And again, we need to give an exact value, meaning that we cannot give an answer with a rounded decimal. So you can't simply go to your calculator and type in sine of pi over 3 and sine of 4 pi over 3 and report the decimal approximation of that. We're going to need to go to the unit circle to get the exact values of those outputs. Since we're trying to find the values of sine, that would be the values appearing in the second coordinate of all of these points. So to evaluate the sine of pi over 3, I simply locate the spoke for pi over 3, and I look at the y coordinate to find the value of sine of pi over 3. That comes out to be radical 3 over 2. And then do the same thing for sine of 4 pi over 3, locating that spoke on the unit circle. That would be this spoke here. And since the output is this number, that would be the value of sine of 4 pi over 3, and that is negative radical 3 over 2. So now that we found the y values of those 2 points, we now can just simply calculate slope, where this is my x1, y1, and this is my x2, y2. So slope, of course, would be y2 minus y1. So that would be negative radical 3 over 2, subtract y1 is positive radical 3 over 2, and then you divide by x2 minus x1, which would be 4 pi over 3 minus pi over 3. And we're in luck, these fractions have a common denominator. So the fractions in the numerator of this complex fraction would be, since negative radical 3 subtract positive radical 3 is negative 2 radical 3, that can be combined into a single fraction. And since 4 pi over 3 subtract 1 pi over 3 would be 3 pi over 3, you can see that we get a lot of things simplify out. 2 divided by 2 is 1, and 3 divided by 3 is 1. So those simplify out, leaving us with an answer of negative radical 3 divided by pi. So note this is an exact answer, meaning it's not a rounded decimal. It's also equivalent to say that this is a closed form answer. So the exact value, or the closed form value, of the average rate of change was negative radical 3 over pi. I could not have guessed that that's with the slope, but given that the secant line was decreasing, remember that we knew that the slope should come out to be negative. Had it come out to be positive, that would be an indication that we had made a mistake somewhere. Just to let you know, oftentimes when students fail to organize their information in these 2 points like I did, they tend to make more mistakes when calculating the slope. So I recommend that you do it that way.